Hello everyone, good morning. In today's video we will be learning furthermore about the C programming language, but before that let's just recapitulate what we have learned in the previous video. In the last video we had learned about computer and computer programming language. Computer is a general purpose machine that can perform complex scientific calculations at a very high speed, but for this we need to give instructions to the computer. Computer understands those instructions in a binary language. Binary is a number system that has only two digits, zeros and one. 0 means off, 1 means on. We can just simulate these events very easily on the computer hardware. So that's why we only use binary language in the computer hardware. We cannot use other languages like hexadecimal and other number system. We had already discussed it in the previous video. We then discussed how George Booley's mathematic paper became the basis for the design of electronic circuitry. Then we just classified the programming languages into three different categories. They were the machine level language, or the first generation of the languages, assembly language, or the second generation of the language, high level language, or the third generation of the language. Machine level language was the lowest level and consists of binary numbers. It directly interacted with the computer system, and it consists of only zeros and ones. So it was very difficult to understand that. We also understood how it understood the language. It consists of operand, opcodes. So there were two different opcodes and one operand, and for every operand it was defined what it would do, like multiplication or addition. Next, when it was not very difficult for writing the code and understand these things, the assembly level language came into existence. The assembly level language consists of mnemonic codes. So these opcodes, different numbers, binary 0, 0, 1, 1, they were given addition or multiplication, different types of mnemonic names. These further reduced programming efforts, and it was easier to write the program. And assembly level language used an assembler to understand to convert the code into machine level language code. So assembler was a system program that used to convert the code that we wrote in assembly level language, and it made the machine, the computer, understand like this is the program that he wants to do this, and the computer would understand that. The high level language, we are understanding C. C is also a high level language, so it uses either a compiler or an interpreter. C uses a compiler, other languages uses interpreter. So it's up to the programmer or a developer who is making the language to make it either compiled language or an interpreted language. There is no basic difference between them. What they do is basically take the high level language, convert it into low level language, what the machine understands, and then it will give us the output. So there was a basic difference between a compiler and an interpreter. That is, the compiler scans the complete code at once, but the interpreter scans the code one by one, and it does the basic whatever the change from the high level to low level language. So it was easier for the interpreted languages to debug the code, and for the compiled level language, whatever the errors what we find, it comes after the compilation process is ended. So we have to again and again change the line of code if we have, and compile it again to see the correct output. Then we went to the evolution of programming, how programming languages evolved. So we introduced Ada Lovelace. She was the master of the programming language. So she was considered as the first programmer, as she converted the analytical engine into an algorithm which made the first program of the history. Then we discussed about different languages like Fortran, COBOL, Basic, Pascal, C++, Python, Java. As we had discussed, Python is the most famous languages nowadays, and it's used in artificial intelligence and machine learning. It is used in Google search engine, YouTube, and also by NASA to develop many rovers and all. They use this language. Then we understood basics about the C programming language. C is basically a procedural programming language. It was initially developed by Dennis Ritchie between 1969 and 73 and was developed mainly to write the operating system. The Linux operating system, Unix operating system is basically completely based on C, and many of the subroutines in Windows also are written in C language. So after this we also installed a compiler dev C++ into our system and then wrote a simple code to understand how we can compile the language and how it's understand with the computer language. So now dev C++ is one of the IDEs that we can use to do C programming. Today I'll be using code blocks for the same thing. So if you want to install code blocks, you can just go to Google and download code blocks from Google. It's a simple process. It's the same as like we installed the dev C++, nothing much. So let's go through this program and let's understand the basics of this. So if you see the first lines of this, I have written a comment section. Next line is the inclusion of the preprocessors and the main function. So if we see line by line, if we describe the structure of the C program, it would be in the first part documentation section, the second is the preprocessor section, third is the global declaration system. Here we don't have, if we describe something like globally, if you want to use it whole through the scope of the program, so that is the global declaration section. It would come after this, and then the main function comes. In the main function there are the logical declarations, whatever the different variables or anything that you want to declare, then the programs and the statements, you want to write any loop or anything. These are the part of the C programs. This main function, it is a part of every program. Any program execution starts from the main in C. So if we see this main function, we can basically divide it into two parts, the declaration part and the execution part. The declaration part is used to declare all variables that will be used within the program. So if we declare anything here like int a comma b, anything like that, so that will be declaration part. And the next is the execution part. So printf if is hello world, this is the execution part of the program. We'll be basically seeing this thing throughout the videos also. So the next part, the execution part of the program, begins at the opening braces. So this opening braces, this one, and ends at the closing braces. Okay, it can also be noted that all the statements of these two parts needs to be terminated with the semicolon. Any line that inside this should be ended with the semicolon. So in all these sections, if you see the C program, this comment section, this is an optional section, so it is meant for any programmer to just explain about the lines what he's going to write. The global declaration section, this is also optional, and we can use the local declarations for execution of program. If we don't define any global values, then also our programs can run. It's up to us. and the user defined function also. This part also. This is an optional section. When we have to write some complex functions, we just remove this from the int function and we call it in the main. We define the functions and call it in the main section of the program. After that, as we had discussed, first when the program executes, it starts from main, and then it will be executing one line by line. Then it will be calling this user defined function, it will be executed, and after that it will be returning us the code. We will define this type of functions in the future videos. So if we say to write a computer C program, the compulsory sections, if we say, are this main functions, the global pre-processing commands, whatever the libraries that are being used, that, and the main if some functions what you want to run. So this is the minimum basic things that are needed for any program. So if we just remove this part of the program code, it will then also run and will give us the output. If we say build and run, it will give us the output. So it's executing the code and it will be giving us the output like what. Here standard library and stdio.h stands for standard input output header file. So there are many preprocessor commands like this. So if we see the preprocessor command, what actually preprocessor does is this. Preprocessor is not a part of the compiler, but it is a separate step in the compilation process. In a C processor is just a text substitution tool, and it instructs the compiler to do pre-processing before the actual compilation. There are different things like define, include, undef. These are different types of preprocessors that we use in the C program. So define, it substitutes a preprocessor macro. What include does is inserts a particular header from another file. Hash undef, it undefines a preprocessor macro. Likewise, if ndef, if we say that, it returns true if the macro is not defined. Basically the directives these are used to save macro in the C program. Hash error prints the error message on the standard error. Hash ndef ends a preprocessor conditional. Hash pragma, it issues a special command to the compiler using a standardized method. So we will be also dealing with all of this in the further videos, and we'll understand how these are used in different programs and practical application of every directives and everything. We will be discussing it. Now, how a preprocessor works in C. A preprocessor is a system software, a computer program that is designed to run on computer hardware and application programs, as we have discussed with before. It performs processing of high-level language. The preprocessing is the first step of language processing system. Language processing system translates the high-level language to the machine language or absolute machine code. This machine code is understood by the system. This is in binary form, zeros or ones. So likewise, there are three different tasks that a preprocessor does on a high level language code. Any other C program, if you say, or any other, whichever language, if a preprocessor works, what it does three things: removing comments, file inclusion, and macro expansion. So removing comments, does removing comments mean? It means that any comment that you write, it is first removed from the code. Like, it is only for the understanding of the coder or a programmer who writes the code, or another person who will be updating the code. So it's not necessary for a program to have that, and it can be skipped while in the process of compilation. So before the code is sent for compiling, we just remove the commented line of the codes. The next part is the file inclusion. File in this step of preprocessor, it includes all the files from library that our program needs. Hash include directive basically. stdio.h means it will be including the standard input output library, and that using that library what we do is we either take input from the user or we push something onto the output devices of the the desktop, the screen of the desktop. We put something out, like in this program we had done, we have printed hello world on the program. So if you see here in this program, this stdio.h standard library, what it does is it includes this printf function. It has been defined in this library function. So other than printf, there is also a function called scanf. What scanf does is it takes input from the user. We can take input and also give the output to the user. This include directive, we can also use double quotes to write this. So the basic difference what it is, if the file name is enclosed within angle brackets, the file is searched for in the standard compiler include paths, and if the file name is enclosed within double quotes, the search path is expanded to include into the current source directory, like for the source directory of this project, whatever it would be. So coming to the third part, macro expansion. Macros can be called as small functions that are not as overhead to a process. If we have to write a function, there is a small definition of code and that needs to be called recursively, then we should prefer a macro over function. What happens while by using macro, we can reduce the program execution time. So whenever like a function is there for calculating the principal of any amount in a bank software, and we are always including we are calling it again and again recursively through the whole program. So what we do is simply define a macro for that, and that macro will be used again and again whenever it is required. So every time we don't have to call the function, so the function call, the function execution, and the function output time, whatever it takes, it will be reduced, and the macro, it will be making the code run faster. Coming back to the code that we had written, if you see this closely, we have two lines of comments here. So these comments, as we have discussed, these are just removed from the code before the compilation step, during the preprocessor step exactly to be said. And here I have written the comments in two different forms. So if you see, if I just write it like this is also a comment, and other way that we can write is just put this and a star mark and then close this by using star mark, and then it will just comment that part. If you just want to comment multiple number of lines, we can do that using this. And as you can see, the whole of my code has been commented. Now if we compile this, I'll show you. If we compile this, there's nothing to compile and no output would be there other than this. If you want to just comment one line of code, just comment this part, printf hello world. Now if you will compile, just let me add one line more, printf function hi, compile this one. As you can see now, the output is only high, and as we have commented this printf statement hello world, it is not coming as the output. So coming back to the code. We can also take inputs from the user. For that, what you want to do is define a value, now this line of code scanf will be scanning your input. So if you want to see what it has scanned, we can print that and show that. Okay, so printf and so this will be printing the output. If you compile and run this, give a number, as you can see, we inputted 1 and it gives us the output 1. So to making it more readable, what we can do is, when we are scanning, before the scanf, just put a print statement. So you will be understanding when the code is executing that it's asking for input. Enter a value. So this line will be okay. Now if you compile and run it again, what will it do? As you can see, enter a value. So just put any integer value there, 34 for example. I put 34, so it will be showing you the output 34. So what it is, this short program is doing is, it's taking the input from us and just printing it out. If you want to do something else, we can do that. Like we can just add two numbers. So let's take this, add one more line, printf enter second value. Okay, again we will scan that value, scanf percentile d. So now we need another variable for this. Okay, so for example, let it be b. So define another integer variable b. This is integer b, and if you want to add it, we can store it in a third variable called c. So int c. I'm defining three different variables, int a, b and int c. Okay, so in the third variable, what I'll be doing is adding first and second, c equal to a plus b. So after adding is comma, as you want to put the addition value, it would be this. You can write a plus b equal to, so just go build and run this code. We're asking for enter one value, so put some value, 33, second value 22, so it should give us 55. So you're getting the value as 55. So what we did now is just write a small program that is adding two different values and showing using a third variable and showing us the output. Okay, we are taking the user input and giving us the output in the format. Okay, so if we just want to, as comments are very important, so what we can do is we can update this line of code. What should we write? Program to add two values. Okay, so make a practice of adding comments after everything that you write. So what I do is, whenever variables are defined, I write the line of comments there defining variables again. So before this function, what I'll write is adding two variables using a third variable. So if we write this comments, what it will be helpful if we see this code again in future. If we want to reference this code, we will be able to understand what it is doing. As this is a simple code, so you must be thinking it's not needed and all, but if you start to write long subroutines of code, it would be very difficult for you to just remember why you had written this function. So it would be better if you make this a practice. Okay, now let's use a macro function to define this code to add two numbers. So what you need to do to define a macro is just use the hash define directive, as we have discussed. Make a function add, for example, define two variables x comma y that will be passed to it, and define the function x plus y. Now what you need to do is add these two numbers. So what I will be doing is just commenting these lines and then calling this function c equal to add a comma b. Okay, now again build and run this function. First value 2, second value 4. As you can see, it's giving us the value as 6. A plus b is equal to 6. So now this same function is using a macro defined to add two numbers. So if we are using this addition function multiple number of times in the future codes, if we write a long subroutine and this add function is used multiple number of times, we can just use this macro function instead of just using this add statement again and again. So this basically, in this way we can just optimize the code and reduce the time of execution. So in this video we learned many different things about the C program structures, what are different types of commenting, how we can put comments on a different line of code. We wrote different programs and understood different line of code what is written. So let's see last time what this program does. So we have written this first line as the comment section. It says that it's a program that adds two value, and this line of code is removed during pre-processing. Next is we are including the basic libraries that are required for running this code. Then we have defined a macro. This macro, what it does is takes two variables x and y and adds them and returns the value. If we will put 5 and 6, we will be passing that. It will be adding 5 plus 6 is equal to 11, and it will be just returning that value to the code. And then the main function. The first function that is called, and it contains variables and all the functions that are different functions, user defined functions that are being called. So there are variables, there are statements, there are functions, and this printf is a function that is in part of stdlib.h, and the scanf is also part of stdlib.h. So these two functions are standard library functions. We can also add our functions too in this code. So we will be discussing all of these things in the next videos, in the upcoming videos. Till then, goodbye.